I've done it again, an entryway shelf packed with unnecessary tech. I spent way too much money on parts, even more time on design, just to get this thing operational. This beast will be loaded with a rising key platform, a weather display, a self-hiding coat rack, a nightlight, and way more tech. Follow along as I overdo it like always, make some big mistakes, add LED lighting, of course, and run a few highly technical tests.
Alright, close enough.
This video is sponsored by PCBWay. Alright, to start things off, we have solid walnut to bend up. First, we need to make a jig to control the shape we're after, using MDF and 3D printed parts. We're going to beef this thing up with some MDF gussets, but first let's run a simulation to make sure the CNC doesn't crash. After that's all cut up, I break the tabs, holding it all together, and sand everything down, ready for the next step. So I have a bunch of powder-coated sheet metal parts for this build, including the back bracket, which will have the stepper motors, the mounting bracket, which will go on the wall, various other brackets, including the coat rack and the key platform, as well as some structured pieces and some miscellaneous diffusion pieces as well. All the pieces you see here are going to be mounted to this plywood piece as the main support. I glue each of these pieces up with some wood glue and drops of super glue to speed this up. For this project, I used some S4S walnut from Northcastle Hardwoods. Great color and very consistent. Link in the description. Now that the form is assembled, we'll add these 3D printed parts for the gradual curve that will go into this. It's a 2.5 inch radius. Here, aligning the pieces and using super glue to attach the 3D printed part to the MDF. Later here, I used 5-minute epoxy instead of super glue because it was really runny. And then lots of clamps and just a waiting game. Next up is soaking and bending the 1/8 inch walnut slats. I cut down the 5-inch wide boards to size on my miter saw. I left them a little bit long so I can trim them after I form them. I clamp the board down in the center section so that it doesn't warp when I put it in the boiling water. I did some tests and 45 minutes seemed to be good up until it wasn't, so I'd probably recommend an hour at minimum. This was quite the process. I thought it was going to be more straightforward, but I had to apply even force across the walnut or else it would split, and you'll see it splitting at the end here. I actually ended up gluing this down and fixing it. Here I am prepping this to be cut, doing two things, making alignment pins for the lamination and the cutout for the display. I'll talk more about this display later, as it is not a traditional display, but it fits just right. And the alignment pins, like I was talking about, we just have to do the other two. But first we need to do a little cleanup.
5 hours later.
Now it's basically a rinse and repeat for the inner section, and then we'll go ahead and clamp it together. Make sure to subscribe for future videos like this one, and also check out Patreon if you want more content. This video alone has 5 updates and community feedback. Again, more time in the water, but it is what it is. Probably thinner board would help. Now we're moving on to the brains of this thing. We've got an ESP32 along with a handful of supporting modules and passive components that need to be soldered together. Now normally, like in my last video, I'd hodgepodge a PCB together, but this time I worked out a breakout board of sorts with JST connectors, and thanks to my sponsor PCBWay, it came to reality fast. They helped make this possible. I'll be hand soldering this board, but PCBWay also offers full PCB assembly if you need it. They do a lot more as well, including CNC machining, which I used for my custom tray, 3D printing for my custom nightlight cover, sheet metal fabrication, and even injection molding. Ordering is easy and straightforward. For my tray, I uploaded the STP file, chose the material, and selected the surface finish, which happened to be bead blasted with a nice, rich, black anodized finish. Thanks PCBWay for sponsoring this video. And I'll drop some of the larger components and get ready to solder like crazy. After that, electronics should be done, and then we can move on to gluing up the main structure. For this, I'm using a sheet of bendy ply, which acts more as a homogeneous core to help prevent the walnut from warping. Plywood is more stable, so that's kind of the idea here. Like I mentioned before, I'm using a 3D printed puck for an alignment jig for each of the laminations to lie on. Now this part was really stressful. I know I say that a lot, but I underestimated the setup and the prep, honestly. Didn't record much of it, and I actually lost the main footage of me bending everything. So all that work on the bending jig, making it look cool, was basically for nothing. I used West Systems epoxy with the slow cure hardener. It gave me some working time, but I was still racing against the clock. After demolding the front curve piece, I work on the top piece. I start taking some critical measurements so I can get everything into my CAM software and prep it for the CNC. I also check for warpage in the walnut, but it was very minimal. From there, I set up toolpaths, run my simulations as usual, and get cutting. In addition to the top section, which has the nightlight cutout, the aluminum tray, and rising key platform, I also cut out the bottom piece. That one has a recessed area for the coat rack to eventually slide up into. It may seem like I'm bouncing around here, but I actually did 2 operations for both the top and bottom piece, so that's what you're seeing. Now I have yet another glue up to combine all of this into one solid structure, but first I need to chisel out the epoxy squeeze out from the laminations to get everything nice and flat so the top piece sits properly. It's going to rest on that ledge you're seeing. I did the same thing on the bottom side as well, but didn't do that on camera. Once that was all cleaned out, I used the bottom side as the reference on my table saw and got cutting. You'll see right here that I kind of stopped using the table saw. I was getting pretty sketched out and I just had that feeling that this was a bad idea. So I just finished the rest of it with the hand plane, which I'm honestly terrible at using. I just bought it. Honestly, just a lot more sanding and fitting and prepping for the glue up. So now I'll get ready for the glue up. We'll do the top piece, bottom piece, and sandwich this together so it's all one piece. Now I'm not sure if this helped at all, but I added some walnut dust into the epoxy just to hide the front facing parts of it. This was a bit more relaxed than the last glue up, but still pretty stressful. The curve wasn't exactly perfect, and you'll see some warpage that'll have to really sand down later on. I really hogged down on this with the sander. It went up from 60 grit to 120 and then finished with 220 all around. Definitely had to do a lot of work on the edges, or I'm sorry, the corners. Now you can see this ugly overhang here. I masked it off and got ready to cut it down. I went back and forth on what I should use to cut this and eventually landed on a cheap Japanese Amazon pole saw, and it actually worked really well. Now finally we get to start adding some cool parts to this build. First up is an illuminated switch that will go on the side to power up the shelf. I full sent blasted a hole into this thing, and luckily the walnut face was not dinged up too bad. After that, the most important, I think, part of this build is the e-paper display. This will display the weather and the time and date and goes right on the front of the entryway shelf. I used a 3D printer backer to secure the display, but realized it was putting too much pressure on the already too thin front face. So I ended up taking the day off and printing a spacer piece the next day, glued it in, and it gave me much more structure. Before packing things in too tightly, I'd like to put the underglow for the shelf in first. So I have this LED strip, a aluminum backer that will add as a heat sink, and this nice diffused acrylic film and some mounting pieces. The LEDs throughout this project are addressable LEDs with an additional warm LED. So yeah, I think it looks pretty good. It's pretty bright enough at least. You can still see some of the LEDs, but I could fix that by doing more LEDs per meter. So I'm trying to get a feel for when this is triggering. It lights up and signals to the microcontroller, whatever you want it to signal. So right now I'm just going to slowly back off until it seems 3.4 to 3.6. So what you're seeing here is the key platform upper and lower limits with these limit switches. And then a few additional components, a millimeter wave sensor and an ambient light detector. Then we move on to the key platform, which rides on a linear rail and uses a NEMA stepper motor to go up and down. I grain ratcheted the key platform with the stationary top of the shelf. It helped that both pieces came from roughly the same part of the tree. Then we'll add some nice smooth linear rails, and of course LEDs. The idea is simple. You press the button, the platform rises, and the LEDs turn on. Press it again and everything runs in reverse to close it up. Now we don't want the LEDs shining straight down and creating a big hotspot, so I tried diffusing them. I tested some translucent white acrylic, but it ended up being a little too milky and didn't let the LEDs shine through very well. You'll see in a minute. Okay, so I have the lights off. Gonna give this a test. I'm hoping it will shine all the way around the edges, but we'll see. Well, damn. Kind of had a feeling that was gonna happen. It looks nice here. It barely shows here. It looks better on the camera though, but it does not show in the front. So I didn't want to do this, but I'm going to have to cut some clear acrylic and then frost it and mount it. It is what it is. I did a final fit up, but first I had to cut down some of the linear motion components. I pulled measurements straight from my CAD software and followed them as close as possible since I was working with very limited space. These linear rails come preloaded with ball bearings, which makes for a really smooth motion. That black piece you're seeing is just a shipping insert that holds the bearings in place. When you're ready to install the rail, you slide it in and the plastic piece drops out. Then it's just the stepper motor bracket, which I printed on my A1 Mini, my Bamboo Labs printer. I dry fit everything and make sure it's reasonably aligned. I use some playing cards to act as shims to get it even spacing. The most important part here is the plate that ties everything together. It captures the lead screw and keeps it constrained, guiding and stabilizing the up and down motion. I make sure to apply blue Loctite on all the screws. And that's it. It's going pretty smooth. We just need to connect some power to this, but we'll do that later. Let's add the PCB and power modules and give this thing a test. This is where the capacitor issue comes back and haunts me. I meant to grab a higher voltage cap, but instead I used a 16 volt one. Okay, moment of truth. This is the next day. I ordered some higher voltage capacitors and eventually replaced them. I connected a bunch of JST connectors, which are little plug-in connectors, just to make it easier because I have to plug a lot of stuff into this PCB. And then gluing in the capacitive touch for the various features on my shelf. I first hooked up the new connections, which is the capacitive touch. So actually you can see it just lighting up right there. Here's one of them that hasn't been installed yet. One on the outside here. And then there's one here. You can see it kind of lighting up. So I'm going to go ahead and hook everything else up and then we'll move on. This is a fun little part, the night light. It runs on a 5-volt addressable LED board, and I'll have it do things like a subtle flame flicker, plus maybe a holiday mode, Christmas, Halloween, that sort of thing. It sits on a walnut puck, so I wire everything up and get it mounted. This is where I love 3D printing. It really comes in handy. I printed a small spacer to hold the LED board in place and create an air gap underneath for cooling. After that, it's only a matter of sanding everything down and fixing it to the shelf. I had PCBWay print 2 versions of the nightlight, one with ribbed features and one smooth. I'm excited to see which one looks better. Now onto the coat rack, which slides up and down with the push of a button. It's basically the same mechanics as the key platform, just scaled up with a larger motor and larger linear bearings to handle the load. Would hold position in a vertical orientation and second get an idea of the maximum weight the shelf might realistically see. Let's add 3 coats, 0.5 equals 2 backpacks. So we're shooting for 55 pounds. Alright, close enough. And here I am testing the inductive limit switches in action, triggering at the top and bottom movement of the coat rack's travel. Coming down to the home stretch, we have the top section with mirror and a few other goodies attached. Let's quickly run through a montage of some CNC action. And finally, we have the mirror assembly, which is the walnut border, the acrylic, which needs to be peeled still. There's a mirror under the film here, birch plywood, and some jigs that will hold it all together. I went back and forth between a wood wax and a hard wax oil, and honestly, they looked almost identical. In the end, I went with the hard wax oil because it cures harder and should last longer between finishing. So I mixed it up and finished both the top section and the shelf with a clear, natural one-coat finish. I almost forgot about this little button. It is the touch for the backlight of the mirror. Shout out to Carbon Method for these bench nuts, which are little foam pads that are great for work holding. This is the backlighting I was talking about. Ideally, I would want these facing outwards, but I was working with a weird stack up of my materials, so I had to make it flat facing. I popped in the two 15-watt USB charging ports as well as the capacitive touch button, and that wraps up the top section of this build. Finally, onto the final assembly. I tidy up some of the wires and put the back panel on with some countersunk screws. Then I snug up the back mirror. You can see a little blown out hole there. I fixed that with some epoxy. And that's it. We'll go ahead and mount it. I just want to thank everyone that's still here and enjoy the final reveal. Also, make sure to subscribe because the next video involves a water bottle.